Okay, so in the first lesson, the first lesson, remember, was called Limits Using Tabular and Graphical Methods or something. And the goal was to use a graphing calculator and plug in like 0.9 and 0.99, remember? And like 1.1 and 1.01. And we used the table feature quite a bit. And then we also just had pictures of graphs, and we tried to figure out what the limit was. Okay. This is supposed to sort of circumvent that, where you don't need a graphing calculator, and you're supposed to be able to do some problems just by hand. All right, so that's sort of the goal. So let's make a little note under our title. Don't use calculator if you can help it. So let's put try not to use calculator. Okay? Try really hard. Try not to use a calculator. Try not to look at the graph if you can help it. Okay? Try not to plug in numbers. So try not to use calculator or plug in numbers. Plugging in numbers will become sort of our last-ditch effort to solve the problem. Like if we really can't figure it out, we'll plug in 0.9 and 0.99 and 1.1 and 1.01. But most problems can be solved without that. And most of the time we don't like plugging in those numbers. Okay, so the first example is really simple. And it's just find the limit as x approaches 2 of 3x minus 4. Okay, so what you have to understand is what the question means. Okay, all it's saying is that we have a line, 3x minus 4. Okay, this is a line. And lines are continuous, aren't they? I mean, you can draw a line without lifting your pen, right? So if it's continuous and it's a line, you don't have to graph this, but just think with me here. You've got this line with slope 3, right? It's passing through negative 4. It's continuous everywhere. So if I were to ask you to study, x equals 2, the vicinity of x equals 2 here, the coordinates of this point and the destination of the curve near this point are identical, right? So if I ask you what kind of behavior is there on left and right of this point, well, it's the same as the y-coordinate of the point, the red dot, see? So this problem can just simply be solved by plugging in 2. So I'm just going to actually solve this by plugging in the 2, and it gives me 3 times 2 minus 4, which is 2. This is the answer. What does it mean? It means if you're over here near 2, not only is the point 2, 2, but the curve, it's a straight line actually, is also approaching 2 on each side. And this is the way continuous curves are. Every point is filled, so the limit always agrees with the function's definition. Okay, so what I'm saying is the first thing you should try on a limit problem is plugging in the little number under the limb. Okay, let's try another one. This one's a little more complicated, but it's example 2, and it's the same style of problem. What is the limit as x goes to 0 of 3x squared plus 2x minus 5 all over x to the third plus 2x minus 1? Your first thought might be, oh my goodness, this thing probably has like asymptotes and discontinuities everywhere. It's got a weird domain, but not at x equals 0. The graph is perfectly well defined at x equals 0. What would happen if I plugged in 0? I would get you don't even have to show the work. It's just going to give you negative 5 over negative 1. In other words, it's going to give you 5. In other words, f of 0 is 5. Right? And if f of 0 is 5, that means that there's a y-intercept at 5. And since this isn't really like an asymptote or anything weird, you can trust that the curve just passes right through that point. And you can trust that the limit, that is the side, each side's behavior, is 5. The point's 5, the limit's 5, everything's 5. In other words, we're going to simply plug the number in. Don't forget, of course, to plug it in everywhere there's an x. Right? Okay, so that will be our first strategy. Just plug it in, plug it in. Okay, let's go on to example 3. What would you do in this situation if it said, example 3, find the limit as x approaches 2 of 2x minus 4 over x squared minus 4? Okay, so I said that the first thing we would always try is plugging it in. So let's try plugging it in. What happens? 2 times 2 minus 4 over 2 squared minus 4. What do you get on top? 0. What do you get on the bottom? 0. What is 0 over 0? Indeterminate. It means we don't know what it is. Does this mean that the limit does not exist? Undefined. Forget this problem, I'm going home.
Yes.
Maybe. It might mean that. But we don't assume that. So people who study limits the first time, all they know is that sometimes they get to plug in the number. So they plug in the number, they get this, and they put D and E. Does not exist. I see it all the time, okay? You're not done yet. The first trick, when plugging it in doesn't work, is to try factoring, okay? So trick 1, try factoring and simplify. Okay? Who knows? Maybe it will make your life a little easier. So let's redo this. We're going to go back to the drawing board. This didn't work out too well. We're going to start over, and we're going to go, let's factor the top and the bottom. And sometimes you realize, wait a minute. Oops, I meant to put a 2 here. Sorry about that. You realize, wait a minute, this x minus 2 cancels out anyway, right? So you cancel it out like this. And then you look at the problem, you ask, can I plug in the 2 now? See? Can I plug in the 2 now? Yes, I can. So I'm going to plug the 2 in now, and lo and behold, I get a very meaningful answer, 1/2. So the first trick after plugging it in doesn't work is to simply factor, reduce, and then hopefully you'll be able to plug in the number. Let's look at the next problem. Example 4. Let's say you're given the limit as x approaches 9 of square root of x minus 3 all over x minus 9. What's the first thing we always try? Plug in the what? What number? The C value. Okay, yeah, it's called the C value. Plug in this, in this case, plug in what? 9. Hoping it will work, and if it does, we're done. Does it work? No. You get square root of 9 minus 3, which is 0. And then you get 9 minus 9 on the bottom, which is 0. So it's 0 over 0, so we just quit and go home, right? No, we just assume that we're not done with the problem. So then we try trick number 1. What was trick number 1? Factor the top and bottom. Kind of awkward here. That might not work. Why is it not working to plug in 9? Whose fault is it, the top or the bottom?
Bottom.
The bottom is what causes issues here. It's when the bottom's 0 that we get stuck, right? I wish that x minus 9 was not there. I wish there was an x minus 9 upstairs. I wish there was an x minus 9 on top. Then it would be gone, and once it was gone, I wouldn't have this problem. Can I get rid of the x minus 9? I would need an x minus 9 on top. Okay? Can I create an x minus 9 on top?
Yes.
I can. I can use a conjugate. So my second trick is to multiply by square root of x plus 3, top and bottom. So trick number 2, try a conjugate. Don't forget, you always have to do top and bottom simultaneously. Otherwise, you're actually transforming my problem. You can't do that. Try a conjugate is trick number 2. So watch, this is like magic. Conjugates always do something nice for us. Almost always. The top is now x minus 9. That's very nice. The bottom is x minus 9 times rad x plus 3. I suggest you do not distribute the denominator. You already foiled the top, leave the bottom alone, okay? look, x minus 9 drops out. Good riddance. Why is that good riddance? Why are we glad it's gone?
Now you have your answer.
Not quite, but we're close.
Oh, well, now you
Now we can do what?
plug in.
Now we can plug in the 9 with no consequence. Like you're not going to have any undefined at all. Okay, so now we will officially plug in the 9. So the goal is usually to plug in the number, but first the conjugate makes it possible, see? Okay, so we end up with 1 over the square root of 9 plus 3. What's the square root of 9? It's actually just 3. Okay, so whenever you see root 9, you're just supposed to write 3. So what's the answer to this problem? 1/6. Now, looking at this problem, do you think you ever could have guessed that answer? I don't think you would have ever guessed that the answer is 1/6. That's why you need techniques. So you need to know the techniques. What's trick number 1? Try factoring. What's trick number 2? Try conjugate. Okay? Let's look at the next problem. Let's say you have, which example are we on? Example 5, thank you. Let's say you're doing limit as x goes to 0 of 1 minus cosine x all over x. What's the first thing we try? It's not even a trick. It's not the first trick, just the first thing we always try. Try plugging it in. Right, so let's try it. 1 minus cos 0 over 0. Let's see, does that work? What is cosine of 0? Careful. Cosine of 0 is actually 1. Okay. So we have 1 minus 1 over 0. Oh, we got that darn 0 over 0 case again. You want to leave? Yeah, we don't leave, right? 0 over 0 is a clear indication that we're not done with the problem, not that it's undefined. It could be undefined. Okay, so that was just a false start. That's all. That's no big deal. What was trick number 1? Factor it. That's not going to happen. What's trick number 2? Conjugate. Do we have a conjugate for 1 minus cosine?
1 plus cosine.
Let's try 1 plus cosine. Okay, so we're going to take top and bottom and multiply by 1 plus cosine x. I call this a trig conjugate. The top becomes, don't forget, you always have to write this lem. The top becomes 1 minus cosine squared. Man, that sounds familiar. And the bottom is ugly, and I'm not going to distribute. Boy, that top looks so familiar to me. Yeah, do you guys remember the Pythagorean identity? The first Pythagorean identity said sine squared x plus cosine squared x is what?
1 minus cosine.
Is 1. So whenever you see a 1 minus cos squared, that's the same thing as what? Sine squared, right. Okay, take out your warm-up from yesterday and look at the very first problem. Look at the first problem in our warm-up yesterday. What was the limit as x approaches 0 of sine x over x? It was 1. Okay, remember you actually used a calculator, you actually came up with that using a table. Do you think we might be able to use that to our advantage on this problem? Do you see a sine x over x in our work? I do. Let's extract it. So I'm going to pull out a sine x over x from this problem. I'm going to rewrite this problem as sine x over x times sine x over 1 plus cos x. This is the same thing as sine squared over x times 1 plus cos x. I just basically borrowed one of the signs on top over the x because I happen to recognize this situation from yesterday. And then one of the rules with limits, something you're allowed to do, is to actually break this into two simpler problems. The first one is this one. The second one is limit of the second part. So a limit of a product is a product of limits. In other words, we can definitely use our fact from yesterday. So what did we say that this was again? 1. It's just straight off of memory. So from yesterday. Oh no, a new problem to work on. What is the limit as x goes to 0 of sine x over 1 plus cos x? Well, what's the first thing we're going to try? Plugging it in. And we get 0 over 1 plus 1. So the answer is simply 0. So I'm glad you didn't go home after we got 0 over 0. You know, you can't just quit and say, oh, it does not exist. The limit does not exist. You can't just do that. You have to say, I don't know yet. Let me play around with it a little bit. So what is trick number 3? Try to extract something you recognize. I saw that sine x over x chilling right there, and I remembered my warm-up from yesterday. So this is trick 3. They might think that's really arbitrary, Mr. Short. If you had waited like 3 days before doing this example, I wouldn't have remembered the warm-up anyway. But listen, this one here, everybody and their grandmother memorizes the first year of calculus. It's right here in the state standards. Students use the special limit that sine x over x as x tends to 0 is 1. Students use it. They don't have to understand it. The calculator told us it was 1, we used it, didn't we? Okay. So what I'd like to do now is, at the top of your paper, I'd like you to write down 2 things that we want to memorize. Okay? So going back to the top of your paper, we're going to memorize that the limit as x goes to 0 of sine x over x is 1. We have no reason to believe it except the calculator told us so yesterday. You won't see the proof for it for at least 365 days. Okay, the other one that we just found was kind of a hard problem. Okay, that was kind of a tough problem. So I suggest we just memorize the result, because I would hate to have to repeat that thing. We just did this problem and we got 0. I think we should memorize both of these. And if you do, you will be glad you did, because you will use them again and again and again. So during second period, Conrad asked me, is there one for tangent? That's like, I love that kind of question. You know, there's one for sine, there's one for cosine, is there one for tangent? Turns out there are ones for tangent, but you don't have to memorize them. Watch. Let's go and talk about one for tangent. Because tangents can be written as sines and cosines anyway, right? So which example am I on now?
6.
Thank you. As soon as Conrad asked that, I put this problem on the board, hoping that we could get an answer. I thought this might be an interesting one because it does give us 0 over 0 when we try plugging it in. Do I need another memorized rule? No, there's a sine x over x buried in here. Okay? Do you remember another way to write tan x? Sine x over cos x. Okay, so let's try that. And let's write that x as x over 1. So we've got, you know, the inner, outer sort of thing. So this is just basically, just kind of rewrite it a few times. Sometimes that helps us, you know. Let's write it as sine x times 1 over x times cos x. That's just Miss Chen's inner denominator, outer numerator thing. See the sine x over x? That's beautiful. We know what that is. We memorized it. So we're going to write limo. I like to call that limo. Limo sine x over x times limo 1 over cos x. What did we say the limo of sine x over x is? 1. Oh no. What about this one? What are we going to do here? Plug it in. Plug in 0. What's 1 over cos 0? That's right, it's 1. The answer is 1. If you want to memorize this and add it to your list of memorized facts, you can, but it isn't really necessary. It wasn't really that hard. Okay, the worksheet you're going to get is fairly difficult. So it has like 18 problems, and the really hard ones have hints. Please finish it for Friday, but start on it tonight. Okay?